Hello students, welcome to Aditya Academy. I'm Dr. Ragini Arora, and today in this video we are going to start our 14th chapter from NCERT, which is probability. So in this video we will be learning all the important terms, concepts, theoretical concepts and formulae which are useful to learn this chapter. What is probability? The word itself denotes probability means possibility of occurrence of any event. So in mathematical terms, probability is the study of mathematics which calculates the degree of uncertainty. That means if an event can take place and there are chances that it may take place or it may not take place, and we have to find the mathematical measure of that happening, then we will be discussing with these things. So this chapter is all about calculating the possibility of any event in mathematical terms. But for that, we should first of all learn how many types of probabilities do we have. So there are two types of probabilities, experimental or empirical probability, right? And the other one is theoretical probability. What is the difference between them? Experimental or empirical probability is, in this kind of probability, the result of probability based on the actual experiment is called experimental probability. So that means if we have performed an experiment and we have listed its outcomes in exact manner. Let's say we have tossed one coin for 1,000 times. So we have performed the same experiment for 1,000 times and we have listed the outcomes. As we know, if we toss one coin, the sample space for that experiment is head or tail. So we have only two exact outcomes. How many times we perform the experiment, we will have only this same set of outcomes for this particular experiment. So either we will be getting head or tail. So now in this case, after performing this experiment for 1,000 exact times, head, tail, we have listed the number of heads as 550 and the number of tails automatically becomes 450 because we have only two outcomes. So this is the result of a particular experiment. Now, in this case, the results could be different if we do the same experiment again. Like if we have tossed a coin for 1,000 times, 550 times we are getting head and for 450 times we are getting tail. So we can, after performing this experiment, we can say that probability of occurrence of head is favorable outcomes upon number of favorable outcomes upon total outcomes. So that comes out to be 550 upon 1,000. That is 0.55. Or in decimals, you can write this, or you can write 55 by 100. So these are the probabilities. This is the probability of occurrence of head, and probability of occurrence of tail becomes 45 by 100. So this kind of experiment, in this kind of probability, we first perform the experiment and then we take out the results to conclude or to give the conclusion for an experiment that what we have come out with as the result of the experiment. Right? So that is why it is called experimental or empirical probability. But in the other type of probability, this is called theoretical probability. It means we do not have to perform the exact experiment, but since we know the possible outcomes, like if I toss two coins here, the sample space for this experiment becomes head, tail, tail. We know that we can have only these four elementary events as outcomes of this particular experiment. So without performing experiment, we can just take out the sample space of this experiment and then we can theoretically perform, or theoretically we can calculate the probabilities of different elementary events. Like probability of one head. Probability of one head is, you have to look for number of favorable outcomes. Favorable outcomes upon total outcomes. So here your favorable outcomes for one head. You have to calculate in how many elementary events we are getting exactly one head. This is tail head and head tail. In both the elementary events, the number of heads is exactly 1. So the favorable number of outcomes is 2 and total outcomes we have 4. So probability of head becomes 1 by 2 in this case. So the basic difference is in the previous kind of experiment, we had actually performed the experiment and then we had noted the result and then written the probabilities to draw the conclusion of particular elementary event. But in this case, even without performing the experiment, we are trying to predict the possibility of an event to happen, right? In class 9th, we had done the probability chapter on the basis of experimental probability. But this year we are going to deal with theoretical probability in our chapter. Next, when we perform experiments, we are bound to have few outcomes. Now this is the types of outcomes. The first one is equally likely outcomes and the other one is not equally likely outcomes. Now what is the difference between them? Like if we have the same possibility of getting each outcome, then it is called equally likely outcomes. Like if we have the same possibility of getting each outcome, like in case of if we are throwing a dice, the sample space for the experiment becomes 1, 2, 3, 4, 5, 6. These are 6 possible outcomes and each outcome is an elementary event for this experiment. So you can see that whenever you throw a dice, you have equal chances of getting 1, 2, 3, 4, 5 or 6. There is no biased behavior like 6 can occur more number of times or 1 can occur more number of times. So there are equal chances of getting either of these results. So they are equally likely possible. Like in case of one coin, we have head and tail. We have only 2 outcomes. See, in case of, you must have seen that in case of tossing a coin, we always start the game of cricket and other few games in which we first toss one coin to decide which team will have the first chance. So that is why a coin is tossed. Why? Because in that case, head and tail have got equal chances of occurrence because they are equally likely possible. There is no difference in the possibility of occurrence of head or occurrence of tail. That is why a coin is always taken as the fair means to decide which team has won the toss and which team has lost it. So this is a fair mean of deciding that because here both the events are equally likely possible. There is no biased behavior in that. The next one is not equally likely possible outcomes. In that case, we can take an example like if we have a bag, in which we have 4 red balls and 2 white balls, right? If we have to find the probability of red ball, see the red ball, we have to write the favorable outcomes and total outcomes in the denominator. So without even looking at the probability, you can say that chances of getting a red ball from this bag is more. The possibility of getting a red ball is higher as compared to getting a white ball because red balls are more in count. So the probability automatically becomes more. Chances automatically becomes higher. So that is why we can say that here the chances or probability of getting red and white balls are not same. Therefore, they are not equally likely possible outcomes. We can see that the balls which are bigger in number, red balls are more in number. So we have higher probability of getting a red ball in drawing a ball from this bag. So such outcomes are not equally likely possible. That is why we do not never keep them as a fair mean of deciding something, right? Next we have types of events. These are 2 special kind of events related to the chapter of probability. So probability means occurrence of something. Occurrence of something. So in that case, these are 2 extreme events. Impossible event means there is no chance of occurrence of any event. So how can that happen? If there is no possibility of an event to occur, then its probability is zero. Such events are called impossible events. So the example you can say 1, 2, 3, 4, 5, 6. The sample space for the experiment of throwing a dice is 1, 2, 3, 4, 5, 6. Now everybody knows that when we throw a dice, we can have only these 6 outcomes. But if we are looking for some other number which is not possible on a dice, obviously the chances of getting that number will always be zero. The probability of getting 7 is number of favorable outcomes. Number of favorable outcomes upon total outcomes. Here favorable outcomes are 0 because we don't have 7 in the sample space. So 0 over 6 becomes 0. So if we are looking for an outcome which is not possible and which is not there in the sample space of the event, so the probability of such events is 0, and these events are called impossible events. Right? The next one is sure or certain events. Sure or certain event means something which is bound to happen. That means probability of these events is 100%. 100% means 100 by 100, that is 1. This is something that is bound to happen. Like if I say we have thrown one dice, 1, 2, 3, 4, 5, 6. If I say the probability of getting a number less than 7. So you can see we are looking for numbers which are less than 7. You can check the sample space of this event. 1, 2, 3, 4, 5, 6. We have got 6 different elementary events, and all are satisfying this relationship. All the numbers are less than 7. So all of them becomes the favorable outcomes. So the favorable outcomes here are 6, and total outcomes are also 6. So the probability of this event becomes 1. That is why it is called sure or certain event. Right? These are the two extreme cases. But in practical scenario, the probability of any event lies between these two events. Probability of any event is greater than or equal to 0 and less than or equal to 1. That means 0 is the least possible value for the probability and 1 is the maximum possible value for the probability of any event. The next is sample space. Sample space of any random experiment is the set of all possible outcomes. So it is usually denoted by set notation, and the possible outcomes are listed as elements in the set. As I told you, random experiments in the case of mathematics or science are those experiments which always yield us a fixed set of outcomes. Like whenever we toss one coin, we will be getting either head or tail. How many number of times you perform this experiment, there is no change in the outcomes. So that is considered as a random experiment. When we throw a dice, we can only have, unless and until it is a biased dice, we can only have these 6 possible outcomes. Right? So when we write all the possible outcomes of an experiment in a set form, this is a set form, these curly brackets including all these elements separated by a comma. So we have listed all the outcomes of an experiment in a form of set. This expression is called the sample space for an experiment. Next is elementary events. Now what are elementary events? The outcome of a random experiment is called an elementary event. Whatever outcomes we can have when we perform a random experiment, we have listed those outcomes in the form of a set, and those outcomes are each and every outcome of an experiment is called elementary event. Here HH, HT, TH and TT are 4 elementary events when we toss 2 coins or 1 coin twice. So every outcome of experiment when written in the sample space Every outcome denotes an elementary event. Next is the probability. What is the exact definition of a probability in mathematical terms? It is the quantitative measure of likelihood of the occurrence of an event. Quantitative measure. Quantitative measure means here we are going to measure it in exact terms. What is the mathematical value? Like we cannot have wild guesses. Like there are 70% chances of it today raining today, or I might go to market today. I may not go to market today. That is, when we are talking about probability, we are going to measure it in exact terms. And in this chapter, we are going to make mathematical measurement of those random experiments which are considered random in terms of mathematics. It is quantitative measure of likelihood of occurrence of an event. Probability of an event in mathematical measure is given as number of favorable outcomes upon total number of outcomes. So if I say I have tossed two coins, what is the probability of getting two heads? See, we have got four elementary events, but now I am looking for the probability of a particular event. That particular event in this case is two heads. Number of favorable outcomes, you can look into the sample space. It is only one elementary event which is yielding the favorable result, that is two heads is present in the first outcome only. So only one favorable outcome upon total number of outcomes is 4. This is how we measure probability in mathematical terms. So the procedure is, first we have to draw or write the sample space of the experiment. Then we have to look for the event for which we are going to find the probability. Next, we have to look for the favorable outcomes in the total sample space. Like in the next case, if I say what is the probability of getting one head, it is not compulsory that one experiment or one event can lead to only one favorable outcome. See, one head, how many outcomes have only one head? This is head and tail, only one head, tail and head, only one head. So corresponding to this event, I have two favorable outcomes. So the favorable outcomes become 2 and total are 4. Probability becomes half. So the next is, let us do this example. A bag contains 6 red and 4 blue balls. So one ball is drawn at random. What is the probability of that ball being blue? So here we have 6 red and 4 blue. These are not equally likely possible outcomes, because here the number of balls are not same for both the colors. The probability of getting a blue ball is, blue ball means number of favorable outcomes here in the numerator, number of favorable outcomes, and then we have total number of outcomes. So that is, number of favorable outcomes is, for blue we have 4 blue balls and total number of balls is 6 plus 4, 10. So we have 2 by 5 is the mathematical probability of drawing one blue ball from this bag, right? Next is, here are few key points which are very important because you will be getting MCQs or one marker questions in this chapter. So these theoretical points actually clear your concepts about probability. The probability of an event is always equal or greater than 0. That means 0, probability of any event is greater than or equal to 0. I had told you earlier that 0 is the least possible value for the probability of any event. So the minimum value is 0. We cannot go to the left of 0. That means there is no negative value for the probability. So the next point is, the probability of an event is always equal to or less than 1. So probability of any event is always equal to equal to or less than 1. So the least bound for probability of an event is 0 and the upper bound for the probability of an event is 1. That means if we combine these two, we get this result. That the probability of any event lies between 0 and 1, both included. Probability of an event can never be negative. See, it's a possible thing that, like we say, the length of any object can never be negative because it's a positive value. Similarly, the possibility of an event can be 0 in worst case if it is not possible at all, but it can never be negative. Now, these are the extreme cases. If probability is 0, we have done it earlier. Probability of event is 0, it is called impossible event. And when probability of E is 1, probability of event is 1, it is a sure event which is bound to happen. Sum of probabilities of all the elements, all the events of an experiment is 1. So that is really very important thing because you must be getting tricky questions based on this concept. Sum of the probabilities of all the elementary events of an experiment is 1. Like if I write the sample space of a dice, probability of getting 1 is 1 by 6. Probability of getting 2 is also 1 by 6 because every element has, here all these are equally likely possible. So every event has got the same probability which is 1 by 6. So if we add them, we get 6 by 6 which is 1. So, similarly, in case of all the elementary events, the sum of the probabilities of elementary events always lead us to 1. Next is complementary event. Now, if PE is the event, then not PE is called the complementary event. Complementary event means if we have like an experiment of throwing a dice. So we know the sample space, it is from 1 to 6. Now, if we consider an event as getting number less than 4. Number less than 4. Now see how many, or you can say less than 5. How many numbers are less than 5? There are 4 numbers which are less than 5. So event becomes number less than 5. So the favorable outcomes here are 4. Total outcomes are 6. So 2 by 3 is the probability of getting a number less than 5. If I say what is the probability of a number not less than 5. So this is the complementary event for this event. If this is the event, this becomes the complementary event. Not less than 5. Now look for the opposite numbers. Here we have two different ways of calculating this probability of complementary event. The first way is this, in which to calculate PE dash, we have total number of outcomes. Here total number of outcomes are 6 minus number of favorable outcomes. Favorable here means number less than 5. So less than 5 here are 4 upon total outcomes. So this is 2 by 6 or 1 by 3. Right? This is one method of calculating the probability of complementary event. The other one is very simple, and in most of the cases we use this formula to solve this. That means first of all we can find out the probability of the event, and then to find the probability of complementary of event, we simply subtract this probability from 1. Like here, the probability of getting a number less than 5 is 2 by 3. So the probability of a number not less than 5 becomes 1 minus 2 by 3. That is 1 by 3. This is an easier way, and moreover, we will be using this formula to do few questions. So you must get acquainted with this. Next is an urn contains 3 red, 4 green and 2 white balls. Red, 3 red, 4 green and 2 white balls. So a ball is drawn at random. What is the probability that the ball drawn is red? So here, first of all, write the total number of balls here. This is 3 plus 4, 7 and 2, 9. Probability of a red ball is number of favorable outcomes upon total outcomes. Number of favorable outcomes for red is 3. So you can write 3 in the numerator and total outcomes here are 9. The probability of getting a red ball becomes 1 by 3. Next, second part says, this is A part. B is probability of not red. So I'm doing this question in both the ways. The first thing is probability of not red. The first formula said you have to write total outcomes minus favorable outcomes. Favorable here means to get red upon total. So the first thing is total outcomes here are 9. Favorable for getting red, because since we are considering red and not red, so red becomes favorable here and the not red means the complementary event. So the favorable outcomes here for red are 3 upon 9. So this is 6 by 9 or 2 by 3. And the second method directly tells us to subtract probability of not red is 1 minus probability of red. That means 1 minus probability of red is 1 by 3. So this becomes 2 by 3. Right? So the next is, now we are going to do some important sample spaces for the very common random experiments we are going to use in this chapter. So the very first thing is one coin. This is a random experiment. So the sample space for this is we only have two possible outcomes, H and T. These are the elementary events for tossing one coin. For two coins, the sample space is head, 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 tail. We have to consider both the orders. Like in first toss, we are getting head. In the second toss, or we can say if we are tossing two coins, the first coin has head and the other one is tail, or the vice versa. The first one has tail and the other one is head. And these are the four different possible outcomes. Third is considering all the different possible outcomes on three different coins, we can have 8 elementary events in the sample space of 3 coins. We have to consider the arrangement of heads and tails in all different orders so that we don't miss out any elementary event in this case. In case of one dice, we have 1, 2, 3, 4, 5, 6. These 6 possible outcomes are 6 elementary events for this sample space. Next is we can have throw of 2 dice at the same time. For that, even we have to consider it. We have to mark that we have 2 dice and one is the first and the second one. So that we can here also consider all the arrangements which are possible for different sets of 2 dice. Like keeping the first event as 1, first dice as 1, we can move on to all the possible values for the second dice, and similarly for the first and second both we can have 6 multiplied by 6, 36 different arrangements or 36 different elementary events for a set of 2 dice. The next one is very interesting and very useful because most of the children are not very much sure about the cards. So try to learn it this way. We have 52 cards in a deck of cards or pack of cards. Out of 52 cards, first separation or segregation of the cards can be done on the basis of their color. The half of the cards are red and half of the cards are black. So 26 are red and 26 are black. The separation according to color, just break the deck of cards into 2 equal halves, 26 red, 26 black. Now the further, red color has got 2 different suits, which are diamonds and hearts. These are the shapes. You must be aware of all these shapes when you have seen the deck of cards. This is diamonds and 13 hearts, 13 clubs and 13 spades. These are suits. We have 2 red suits, and here we have 2 black suits. This segregation is called separation of suits. So we have 4 suits in all. In a deck of cards, we have four suits in all, out of which two are red and two are black. First suit is, or in any order you can say that, one suit is diamond, one is heart. These are two red suits. Clubs and spades are two black suits. Now when we go inside these suits, every suit has got 13 different cards. Like first one is ace, and then from 2 onwards up to 10 we have 10 numbered cards, and after that we have J, Q and K. These are 3 face cards in one suit. 3 face cards in one suit. Similarly, we have ace, then 2 to 10. These are the 10 numbered cards. Then we have J, Q, K. 3 face cards in hearts also. Similarly, we have 13 cards in clubs and spades. So from ace to 10, these are 10 numbered cards. J, Q, K. 13 cards, right? So ace to 10, ace to 10, ace to 10, and these are the 40 cards. And if we talk about face cards, we have 3 face cards in one suit. So 3 multiplied by 4, that is 12 face cards are there. Right? This J stands for Jack. Q stands for Queen. And K stands for King. Right? Jack, Queen and King. Every suit has got 3 face cards and we have 4 suits. So that means in total we have 12 face cards. So this was the terminology regarding to the deck of cards. Now if you want to practice like what is the probability of getting one king, if you draw one card from the deck of cards, what is the probability of getting one king? So you have to look for how many favorable outcomes are there, how many kings are there. See, one king is in this, diamonds, hearts, one king is here. We have 4 kings in all. So the favorable cards are 4 and total number of cards here is 52. Probability of getting one king becomes 1 by 13. This way we practice probability in cards. Next we have, if we have probability of diamond. What is the probability of getting a diamond card when we pull out or draw one card? How many diamonds are there? We have 13 diamond cards. So favorable is 13 and total is 52. So it's 1 by 4. So I hope this is clear now. This was all about the theoretical things. We have learned all the important terms, formulae and sample spaces for different random experiments that we are going to use in this chapter. I hope you liked watching this video. Please subscribe, like and share it with your friends. Thank you.